Hello friends. So today's video we will see the other matrix method, that is stiffness matrix method. In previous video we have seen flexibility matrix method, which is called as a force method. Now we will see stiffness matrix method, which will be called as a displacement method. Why it is called as a displacement method? Because in this particular method the displacement, or say joint displacement, are have more importance. So in displacement method, stiffness method, we have to find out KDI, kinematic degree of indeterminacy. What is kinematic degree of indeterminacy? We have to find out how many joint displacement we have in a particular structure. So that particularly we have to find out first, and according to what is the number of KDI, that is kinematic degree of indeterminacy, we have to form a stiffness matrix. So in next step we have to find out formation of stiffness matrix K matrix. So in this method we have to follow a compatibility equation. What is the compatibility equation here in this stiffness method? That is nothing but theta matrix. It is also called as a redundant matrix, as we have seen in flexibility matrix itself. So the theta matrix, that is redundant matrix. Why it is called as a theta? Because we are dealing with the joint displacement here. So as this particular method is a displacement method, so there will be a matrix of column matrix, and it has elements of joint displacement only. That's why it is also called as a displacement matrix also. Okay, so that is unknown over here. That will be equals to inverse of K matrix. K matrix is nothing but your stiffness matrix, and once again it will be a square matrix depending on the number of, what is the number of kinematic degree of indeterminacy of a structure. Next you can say in bracket P matrix minus PL matrix. So what is meant by P matrix and PL matrix? First one is a P matrix, that is nothing but the given force or moment matrix. Once again it will be a column matrix, because that will be contain only a force or moment matrix depending on which joint displacement we have taken as a redundant over here. Let us suppose we have taken theta, that is slope, as a joint displacement. Then we have to find out how many moment is given at that particular node itself to find out P matrix. So that particular value will be given in the particular problem itself. So that means given problem itself will contain this value. Okay, and next one is the PL matrix. Once again it is also a force or say moment matrix, that is action matrix, which will be produced due to external loading. So what will be the external loading condition on the structure? That will be very important factor to find out the PL matrix. Once again this PL matrix will be the columnar matrix. Okay, so this is your compatibility equation you will be using. Next is the main thing is what is meant by stiffness. Okay, so stiffness is nothing but the moment or say action produced, moment or say force produced. Okay, moment produced due to unit displacement at that node. Okay, I will say moment because we will consider only joint displacement as a slope only. We will not consider as a say translation displacement as a redundant over here. So we will take only rotational displacement, that is slope, as a redundant. That's why I am taking only moment as a say action. So what is the definition of stiffness? It is nothing but the only simply moment produced due to unit displacement at a node. Okay, so if K matrix is concerned, there will be element, say Kij is an element of your K matrix. Now what is I and what is J? So Kij is nothing but moment produced at node I. Okay, first denotes at node where the moment is produced. First I denotes where moment is produced. So moment produced at node I due to unit displacement is given at node J. It has to be J. Okay, that means second ordinate is J is where unit displacement is produced, is given. Okay, So that particular will be equals to Kij, and from that you have to find out your Kij. That means each and every elements of your K matrix, and finally you have to use compatibility equation to find out the unknown redundants over here. Okay, I guess this basic information is very essential or sufficient to solve any particular problem. So in next video we will see a particular problem by solving. So that means this particular concept will be clear to you. So thank you. If any doubts you can ask me directly by contacting my WhatsApp number. Thank you.